if we by mistake mute you, you just have to unmute yourselves, okay?
Okay.
Just in case. All right. Okay, we're gonna let them in now. Okay, admit all. Here they come. All right. Welcome. Thank you for joining us.
Yeah, I saw someone.
Right.
What?
Here we go. Welcome, everyone. Thank you for joining us.
Wait.
Hi, everybody. I'm Andres Martinez. I'm a NASA engineer. And my office is only 10 minutes away from your schools. Remember? Welcome to Destination Space. Destination Space 2021, a series of incredible talks where we've invited these incredible scientists and engineers to come and share with you what they do at work. All right? And a little bit about how they got there. What do they study? Where do they come from? Today, we have another special guest. Today, we have Dr. Juan Fernandez. Remember, in April, we are celebrating planet Earth. When we started in February, we took you to Mars, remember? Together, we saw the landing of the Perseverance rover and the Ingenuity Mars helicopter. And then last month, we went to the moon. I invited all my colleagues from the Advanced Exploration Systems Division, the division that I work for. And we went to the moon with you. Well, this month, we're celebrating our beautiful planet Earth, our home, our only home. And today we have Dr. Juan Fernandez-Saldivar, who's an optical systems engineer for a company called Planet Labs in San Francisco, California, not too far from here. Okay, Dr. Fernandez has been working in this field for over 12 years and has actively participated in 100 payloads launched to space, 100 little satellites, or sometimes they're big satellites, all right? And he's worked on these projects and put all these payloads in space. Today, he leads the production and testing of current payloads and the design of future space imaging systems to see how the world is changing. Today, he's going to talk about what his company does, Planet, imaging our beautiful planet every single day. Please help me welcome Dr. Juan Fernandez, everyone. Remember, we only have one rule, and that is to keep our mics muted. Once he's done with his presentation and sharing his incredible work, we're going to have a Q&A session, all right? You're going to be able to ask him a bunch of questions, all right? Okay, Dr. Juan Fernandez, please welcome. Welcome to Destination Space. You may now share your presentation. I think you're muted still. Yeah, we can hear you now.
Yeah, you guys can hear me? Okay, let me, in presentation mode. Hello, everyone. I'm really excited to be here. When Andres kindly asked me to participate in this, I couldn't wait. Time went so fast, so I'm super excited and thankful to be here talking about space, talking about the planet, talking about technology, spacecraft, satellites, big satellites. In this particular case, it's small satellites, such as like the one you see just right there. It has just been deployed. It's just looking at Earth. This is what I want to be talking about today. What is that I do? Why it's important? I'm going to be showing you amazing pictures, and near the end, I have really cool surprises for you. So let me start with this presentation. I'm going to tell you about who am I and what is that I do. I think it's pretty cool, and I'm going to go through that in a bit more detail. Basically, is I work on cameras that take pictures of the Earth from space. Why this is important, why I particularly think that we need to see this, is we need to see the world and how it's changing. This is home, we live here. So We have to care about our planet. We have to care about our world. It doesn't matter if it happens here or anywhere in the planet. We have to be careful and take care of the planet. Now, we cannot be everywhere, but satellites, they can see everywhere. So how do you do it from space? And once you're up there, what is exactly that you can see? Can you see fields? Can you see cars? Can you see planes? I will try to explain what are the capabilities. And at the very end, I would like you to use your imagination. If you have the opportunity to build, to see the pictures, to do a sat, what is that you would do? What would you paint on a satellite, for example? And that's a hint of the surprise we're gonna get at the very end. So let me start introducing myself. Andres made a very good introduction. I'm an optical systems engineer, which means I work with cameras and lenses taking pictures of space. As you can see, I'm here, and this is the same as my background. This is the place that I work. It's very, very cool, not only for being here. Every day on my my documents and everything, there's new pictures of hundreds of satellites every day. It's fascinating. You have to be careful because you watch them all, you're not going to do anything in the day. So you watch the good ones and then you carry on. I've been here for over 2 years. I'm in San Francisco, in downtown San Francisco. And in these 2 years, I've been working on a small satellite, which is the size of a loaf of bread. And I've launched hundreds of this. I put a list there ever since 2019, 3 launches in 2020 and 1 in 2021. The one that I mentioned there failed, the one in 2020 with 5 superdoves. Things that don't always go right. So you have to cope with that. Over the years, I've worked in spacecraft, which is this small. Let me see if I can point you here in my background, or as you can see here in between my 2 colleagues. But I've also worked with larger ones. How big? Well, not as big as NASA. I mean, like size of a school bus, but definitely like the size of a fridge, or maybe like the size of a washing machine. And things, they get smaller and smaller and smaller till you get something this small. It's smaller, it's cheaper, you can launch many, you can produce them a lot faster. That's the beauty. That's why I'm going to concentrate on this particular satellites called the superdoves. And this was basically the concept that Planet had. And why I enjoy so much working for Planet is because our mission as Planet company is to image the planet every day, the whole world every day. Why we do this? Because we want to see it, because we want to give access to people, and because we want to action things. If we see that things are changing, what can we do to improve things? So that's why it's really important. Now, as I said, we live here and we do various things. We have farmers that they can take care of the food that is brought to your tables. We have deforestation, unfortunately. We have disasters, floods, eruptions, all sorts of things. And there's also humanitarian reasons why we do it. So that's why it's important. And I'm going to go through how we do it. What does this mean? What does taking pictures of every day mean? Well, this means that we get over 3 million images every day. That's what I said. If I were to look at images all day, I wouldn't do my work. So it's many, many, many pictures of about 300 million square kilometers per day. This is twice the landmass of the Earth. We concentrate on the landmass. We don't see the seas and the oceans and everything on every single point every day. It's really landmass. And on average, we get 1,300 images of every point on a landmass. It's a lot of data. It's a lot of data. It's 25 terabytes per day downlink. This is a lot. It's not something you would be able to store in your computer. It is massive. And this is a result from about 452 satellites being deployed from at least 10 different rockets in many sites, many countries, launched from different rockets and downlinking the information to different points on Earth, as we can see here. So these are just some numbers for you to get the idea of how challenging this is. Let me show you how the technology looks. So when I say so many satellites, how do they look? Well, they've got all sorts of shapes and sizes. As I said, this one, for example, it was probably the size of a washing machine. This is a company that we acquired. I was lucky because I used to work in another company and my optical lab was behind this wall. Then the company that I work for now, Planet, they also acquired these SkySats. These are large spacecraft. And they allow you to see smaller things on Earth, higher resolution, we call it. I'm going to explain that, so don't worry. But really, the main thing is the doves and the super doves. These are the concepts that they have evolved. And you will see how it all started. I'll tell you the story. But it's not only so what happens in space, what you have in space, but what happens on ground. We have ground stations. There's an antenna. This is an antenna that is covered. These are other antennas that they open. Some of the things that you will find, and I find really cool, is the drawings, the designs. We include art in our technology, which is something really good. We even have the time to do it, and we would like you to participate. So why I think this is cool? Well, one thing is cool having the technology and having many of this to test. So on my day-to-day work, I grab one of this, the ones that are here. I just grab, I handle it, I check it, I test it. So it's super cool for me to do the production. And it's not only the technology, the people. Just before COVID, we were able to be all together and work on this. And it's the people, it's the technology, but also the other really cool things. You may imagine, what is this? Is this the fridge that you're talking about? Sort of. This is a vacuum chamber that mimics the space environment. There's no air in space. So you suck all the air out and you put your spacecraft there, and then you test it. So it is really, really cool what I do every day, I think. I haven't been lucky enough to be to a launch, but I always in the last mile before we put the satellites and pack them in these boxes, and they get shipped to the launch site where they get put into these dispensers that you see, and they pop out in space right after the rocket gets there. And I would love to go to a launch site and experience that firsthand. I haven't, but we have as a company, so I feel proud to be doing that. On the early days, we used to deploy from the International Space Station. So this is a real picture of our doves and super doves popping out from the International Space Station. These days, we don't use the space station to deploy our sats. We use a number of rockets. And these are various families. I'm not going to go in details, but just to give you the idea that there are various types of rockets. Things sometimes they go bad. So we cannot guarantee that everything that we put in a rocket is gonna make it to space, for sure. But we have to learn from it. That's the whole point. Don't be put off by failures. You have to keep trying. And once you succeed, what is it you would get? Well, you can get many satellites that I'm going to try to explain how they operate. So we have the Earth relative to the sun. This is the illumination. We're kind of spinning relative to the sun. And our satellites, they go north, south, north, south, north, south. These are the small ones. You can see 3 meters on the ground, and they have different colors that I'm going to explain. There are other bigger spacecraft that they can see finer details, and they could be put in the different orbit. So while the small ones, they go north and south, they cross every point on Earth at the same time. It's 10:30 in the morning or it's 12, it's always the same time. The other ones that you see more inclined, they can see things at the same point on Earth at different times. You can see something in the morning, in the afternoon, not in the evening because there's not a lot of light. We see visible. We don't see anything that is not based from light. And just to give you an idea, these satellites, they travel about 4.8 miles per second, 4.76. So they go around the Earth every 90 minutes. So you see them spinning like crazy. Well, that happens. They go 15 times in a day around the Earth. I think that's pretty cool. And once you can do that, what is that you can see? Well, you can see the entire world. I don't know what happened. Let me go to the next slide. Yeah. So, but why are we doing this? Why are we putting lots of spacecraft to take pictures of the Earth? Well, if we want to fix things and change things, we cannot fix or change things that we cannot see. So we can see the whole Earth. And this is an example of our data from years, and as it changes by the month, we can see the ice and the snow coming south and then retreating. And this happens on a yearly basis. So there's certain things you can see every year, every month, or even every day. And there are things that you could see at scale, like the whole continent, or maybe a country, or maybe a local area. But why would you do that? Well, it is our planet, remember, so we have to take care of it. We have to take care of the planet and the people. So when there's a disaster and there was too much rain and too much snow, or there's disasters such as this, there was flooding. So things they get damaged, and we really want to have the government to have the capability to deploy emergency activities. We want to save the people and help the people that they are under those distressful conditions. Other things we can do, it is very important for the planet, is see the deforestation. Every day an illegal road appears, they're just logging trees in various places. So we have to see them all. We have to be very careful. So all trees, they can disappear forever if we're not careful. I'm going to show you some more examples of that. Other examples of flooding, let's say we look at this beautiful coastline mid last year. And then what happened early this year? Well, look at what the floods caused. So this is the changes that we want to see. When I say see the change the world, that's what I mean. It's not only water. We can see fires. I mean, in California, as you know, this is something that happens all the time. So what happens is you can go through an area. This is not in California, this is in Australia, as an example. And this is how things look on the 1st of February this year. By the next day, fire happened. So we couldn't have been able to do this if we were not there at the right place at the right time. And we want to be at every place every single day, at least once a day at one time. So this is why it is important. Regarding deforestation, we can see large areas. So we can see here, there's a couple of rivers, and we see that there started some deforestation in some areas. This is in 2017, this is in 2018, this is in 2020, and this is earlier on this year. Let me flick back and forth so you can see the changes, right? From there to there. Many trees, they've been lost. We need to save our planet. Other examples of river flooding, you don't need to be by the beach to get a flood. You live near the river, like in Kentucky earlier this year, and by March it was already flooded. These are all very recent data. I wanted you to see as recent as possible. So these are all the things that we can do. But what made all these beautiful pictures possible? I hope you find them beautiful and amazing. But what enabled this? How it all started? Well, what is it they're doing? They're using technology, but it's not only the technology, it's the technology with the intention that people they had good intentions. So they said 3 scientists back at NASA in 2010, they say, oh, could we just mix the technology of a mobile phone? You wouldn't find this one any modern by today's standards, but this was a modern phone in those days. And it could be used to exploit technologies and put in really, really tiny CubeSats to do things. This is, for example, the communication antenna. So the 3 founders of this company, they were inspired by that. And like many companies in the area, it all started in a garage. So they all gather and they say, oh, wouldn't it be cool to put satellites in space and see the world every day? Yes, let's do it. And they succeeded at that, and they have evolved. It's what it's called like agile. So let's get the money, let's fundraise, let's do it, let's demonstrate, and let's improve things. So over 6 years, we have 14 doves, as we call them, being built. And on every dove, we try to improve something. So we take the technologies from lenses, from cameras, from navigation, from all sorts of really cool technology. And within 3 to 6 months, we've designed them. Next month, we're building them, and then we're iterating. And we launch them in space with some art. Again, just a hint of the surprise that's coming near the end. So these are, and actually it's coming a bit sooner. So these are the satellites, and what is that they can do? Well, they can measure 8 bands, and I'm gonna go what 8 bands, 8 colors, let's say. And resolution is something the size of 3 to 5 meters. My arms, they're not big enough, but I hope you would get the idea. And the total time to build a satellite is 17,000 minutes. So it is about 2 weeks. So when I show the satellites here, or the ones that I've showed previously, I work with my team testing them. And within the period of 2 weeks, we got a sat fully built, fully tested. That's why I love my work. I really do. So once we do the technology and all that, what is it we can see? Well, we can see the three things I kind of mentioned. What are the three things that are key and important? One is spatial resolution. That's how we call it. What it means how big or small an object is. Can I see a truck? Can I see a car? Can I see people walking? Or I can only see like big areas, such as the one we see here on the right. All we see is the lake and the area around the lake. We don't see small boats, we don't see people. The other thing is spectral resolution. What is it? Well, it really, what color or colors is it? Is it just this frozen water and then this dry land? Or there's vegetation, or there are many other colors? The other thing is, how often can I see things? If I was not flying every day, I'm probably going to miss it, because I'm probably going to be seeing things every month. That's not that good. So I'm going to give you examples of each one of these three. And I will take any questions at the end. So let's imagine a big sat. Let's start with resolution. So I said, here you can see the river, and you can, the concept is how small things can be so I can tell them apart. So if there were two people there, I wouldn't be able to see them, never mind them being apart. So there are other rules here about how you can actually distinguish, and I'm not going to go into details of the pixels. I just want you to get the idea by an example. So in this case, a Landsat, this is a NASA instrument. It is an old instrument, very big. It could see the Earth in massive scale. It is a global reference, but it could only see 30 meters. So with this resolution, all you see is like blobs of green and other areas. You cannot really tell them apart. If you increase your resolution, or now you can see something smaller, now you see 10 meters. Ah, this is a city, and I can see some of the roads. What if you go lower? Well, this is where our superdoves, they play. So imagine they are smaller, but they can see a bit more detail. It's one aspect. It's not the whole truth, but I just want you to get the idea. And we also have a bigger satellites they can see in a lot more detail, like 0.5 meter or 1 meter. Let me flip back so you can see what is resolution. Is the objects you can see. These are not taken at the same time. You may see other differences, but this is the fundamental concept. Now, colors, resolution. We can only see from the rainbow that we sometimes see after it rains. We can only see up to certain colors. Our human eyes, they see blue, green, and red mostly. Anything after that, we cannot see. But we can play tricks to do cool things. So we can take our blue, red, and green that we see. We put a filter in front of a camera, and you would argue, why is this black and white? Well, the camera is black and white. It doesn't see the colors, but because they come through a filter, this is what the camera sees in that color. The camera doesn't know about colors. It is you doing a true color composite where you combine and project these three colors, and you say, ah, now I get color. And you can have all sorts of colors. This is what I want you to know. We have in our original design, these three colors, blue, green, and red, plus an additional near infrared. We humans cannot see it. And now in the next iterations, we change the shape, the shades of colors, the rest of the quality of our colors became a lot better, a lot more defined. And now in the current ones, we have 8 bands. Some of the really large spacecraft, they have multiple bands. And now we can play with the colors. Now we can say blue, green, and red, they could be anything that we want. We can project things in different colors. And let me give you an example. Why is the top image red? Well, vegetation, we think it's green. It is green to our eyes, indeed, but it has other colors like near infrared, but we cannot see near infrared. So what we do is we project the color that we cannot see in a color that we can see, and we say, oh, there's a lot more difference between this red and that black. So this is vegetation, this is water. It wouldn't have been easy to see it here. So you play with colors, and you can get really, really cool images like this. This uses the near infrared, that if the water should be black, but because its eyes now it's becoming reflective, and it looks really cool. Other things, you can play with coastlines and assign different colors. And now things, they pop to your eyes, and scientists, they can say, oh, if it looks this color and this combination, it could be this thing that we're observing. And more colorful examples. It depends what is that they want to see, how they combine the colors. I would like you to use your imagination to say, oh, I want to combine all these colors. There's a couple of experiments that I'm going to send as a link near the end. Ultimately, we don't want to see color. Scientists, they want to translate that into an actual measurement. And this is what they call normalized difference vegetation index. This tells them about the chlorophyll. It tells them about the health of the plants, not just the color. How healthy are our plants? This is very important. They can also quantify our gray areas, even though they look like color, and we see, oh, some areas that were burned by fires, now they pop up a lot more. We can identify them more clearly, playing with the colors. We could even play with more colors and make this thing, which is a burn area index. So now it's translating colors and images into information. That's what is going to change the world. That's what is going to save the world. The last element is temporal resolution or cadence, revisit rate. So some satellites, they're very big and they can only see a reduced amount on ground, and they can only see one place every 16 days. Others, they can see every 5 days. Others, they can see 1 to 3.5, 4 days. We can see things every day. That's the title of the presentation. So if we see things every day, like here with our PlanetScope data, you may have clouds. You cannot see through clouds. So if you get a cloud, you're not going to see what's underneath. But the more you look at, the more successful acquisitions you can get, as you can see. If all the access you have to the data is every other week, if you have clouds on 3 days, 4 days, you're only left with 2 observations. The more, the better. So that's what I would like you to learn and to understand. Now, why is the more the better? Why the more satellites the better? Why combining them? I'm not saying that our satellites, they're the best. I'm just saying that they do things differently, and you have to think differently. And you can be clever and combine the various sats with the various resolutions that I showed you, with the various revisit times, and do even more clever applications. So on the left is kind of the really basic raw data in red, green, and blue. And you say, what is flickering? Well, maybe there was a cloud, maybe the satellite missed some of this target. So it's difficult to do analysis on what you have on the left. Scientists, they found it difficult. So they started combining multiple satellites and gap filling, i.e. when there is a black area or a white area, let's try to bring another satellite in and complete the information. And this gives you now something which, if you were in space looking at the same spot on ground and there were no clouds, you would see how the fields that they generate our food, they change. Agriculture can seriously benefit from that. But again, you can translate now these colors into this vegetation index and now have quantifiable data. Scientists, they love it. They use that all the time. So that's why it's important. I hope what I've presented, it was of your interest. I think what I can conclude, and I hope you agree with this, is that working with satellite and space technology is great. I cannot have enough of it. This allows us to, for Earth observation, tomorrow it's Planet Earth Day, so we have to celebrate this, see the changes. Now, I also showed you that space is not easy because of the many complications, clouds, rockets, but it's fun. It's really good fun. I hope you can find a way that you can relate yourself with how can you do in space. I hope you also got clear the different applications for colors. And finally, I would like to use your imagination. So what would you do if you could see a daily change of what? You don't have to answer me. Please have a think. You can add it in the chat. You can do all sorts of things. But before I go, I would like you to invite to this Creativity Planet. So here's how you can participate. You can download a template, and this template will allow you to know the size of one of our side panels. And with these side panels, you can draw something and it will fly in space. So I will be sharing all the links right after my presentation. What I'm gonna do now is, before we get into the questions, let me show you some cool links that I'm gonna be sharing with you. I'm gonna I'm gonna add the chat. Where is it? I cannot see this. Oh, where is it? Yeah, the chat. Here it is. So let me get it at hand. And one of the very cool things I want you to look at is this link. And I hope you can copy this link and see it. It'll take you to this page. On this page, you can see our superdogs. You can spin them. You can see them from every single angle. But more so, you can use your mobile phone or tablet or anything and put this in an augmented reality. You can virtually put that floating sat on your table. I suggest you try. This is pretty cool. The other thing is, and let me send you this other link. This is to get your art in space. I'm gonna share the link and put it here in the chat so you can follow it. On that link, you will get this document with a template. Let's copy that one so you don't struggle finding it. This is the template. You print it, you draw your own thing, you send it to us. I cannot guarantee that every single drawing is gonna fly, but please try. And the final two things is I'm gonna complement this talk with something that my previous colleagues, they've already done. So there's cool videos about launching in space. There are a lot of questions and answers from some of our space operations. And also from one of my colleagues, and she also does optics. She did this pretty cool thing. She not only explained about optics, but she also made some activities, making rainbows, water prisms, soapy shapes prisms. I'm not going to go through this. I don't have a lot of time here and probably have already eaten enough, but I have all the links here and I would really, really like you to participate. And I think with that in mind, probably let's go with some questions.
Wow, that was such an amazing presentation. Thank you so much. So now we're going to go ahead and go to some questions. Looks like Mateo has had his hand up. So if you want to go ahead and unmute yourself, we can get your question asked.
Hello, Mateo. I cannot hear Mateo. I don't know if he can type his question. Like, I don't know. I think he's unmuted now.
Go ahead, Mateo.
Yes. My question is, what happens if the machines that the camera goes to space and gets lost in space?
Yes. So sometimes what happens is we have failures. So the spacecraft or the camera can start not controlling and spinning. It gets lost, as you described. It loses power. It cannot charge anymore. And unfortunately, it cannot control itself. It just keeps spinning faster and faster. It comes closer, and eventually it disintegrates up in atmosphere after some years of not functioning. So there's always the risk. You're right. Sometimes we lose some of our satellites. We have to be careful. That's why we also need to be very careful when we test them. And yeah, that's a good question.
Okay, let's see. Erin Ho from Miss Kopensky's class has had her hand up. So if you want to go ahead and unmute yourself.
How do you launch a satellite?
How do you launch a satellite? Am I hearing this correct? Yeah.
Yes, correct.
Yeah.
Yes. So what you do is you build it, and let me quickly scroll back. Maybe this is going to illustrate the point. What you do is you build your satellite let me go through the very first ones. You build your satellite, and then you put it in a rocket. It doesn't go straight onto the rocket. So you don't put it outside the rocket, you put it at the top of the rocket. Let me scroll back again. So you put it right here at the tip of the rocket. Once it's in space, that opens, and there is another thing that springs the satellites out. So these cases are not the satellites. The satellites get put in these dispensers. These, they go at the top of the rocket. The top of the rocket opens, and then this pushes the satellite out, and off they go in space, just like I showed here. That's after they leave that capsule. That's how they will start going and imaging the Earth. That's a good question.
Okay, let's see. Logan has had his hand up. So if you want to go ahead and unmute yourself, Logan.
I cannot hear. Was I late?
Oh, Logan.
Okay.
Yeah. Let's check again. Hi, Logan. Let me see. Oh.
I'm going to add a note also to Mateo that he said, what if they get lost or they fail? Be careful. This that I'm wearing, it is to prevent any electrostatic discharge on the satellite. So we're very careful with that. I don't know if the next question is now unmuted, or we can get it.
Okay. I think we could not hear Logan. So let's try Miss Moeller. Hi, Miss Moeller. How you doing? And Ariel, welcome again.
I have a question. How did you get interested in optics?
We were wondering if you like to take photos as a kid. Has this been a lifelong interest of yours, or did you always know you wanted to study this field?
Oh, that's I love that question. Well, my background is in electronics engineering. So I wanted to do the electronic thingies. I didn't even know about space and satellites when I was a kid. Now you see lots of things. Now this is the best time to be a kid and get involved in space. When I was your age, I didn't know about that. So by doing the electronics, then I started playing with cameras, and I was a photographer. And then I went to study in the UK. I wanted to learn more. And that's when I started to learn about satellites. And eventually, after I did my master's in satellite communications, I thought, ooh, on the Surrey Space Center, it is a space center. That sounded like super cool. They building satellites. I want to do it. And then I got interested, went in there, and my PhD was in observing volcanoes, and I developed this instrument. So for tracking volcanic gases. So it is not something that I knew when I was a kid, but as I started finding out more, I got fascinated, and now I couldn't do anything else. I think getting every day to work, exploring various images of various places, grab a satellite in my hands and test it. It's so cool.
Well,
Thank you for your question.
And thank you so much for being here for our students. We're so appreciative.
No, that's great.
I have to add just one quick note. So when I met Dr. Fernandez, it was at a space symposium that was organized by the United Nations. And my reaction was that he was super cool because he was walking around with a camera that had a lens like this long. Okay. And I thought, whoa, that is such a cool camera. So anyway, let's do one more question.
Okay, let's see. Chevelle, go ahead and unmute yourself. And can you turn on your camera? We'd love to see you. Hi, Chevelle.
Hi, can you guys hear me?
Yes.
We can hear you. There you are. Hi.
Okay, I actually have like 3 questions. So have you seen Pluto and small planets, and what else orbits around the Earth, like very small?
Let me see if I understand your first question. So you said if we have taken photos of planets. Was that your question?
Yes.
Okay, so normally as we point our satellites, they point towards the Earth. They don't point out in space. That's not to say that we don't do it. We have done it, but as an experiment. We use not so much of planets, but stars. So we flip the satellite, we point it up, and let me actually stop so I can probably use my hands. So we pointed not down to Earth, but up to the stars, and we see how the stars look, and we make sure that we can control the satellite. It's part of our commissioning, as we call it. That was your first question. Your second one was on the orbits and how, but I didn't get clear what was the question regarding orbits.
Yeah, she's wondering what else is orbiting our beautiful planet.
Oh, I mean, tons of satellites, lots of space debris, everything that the rockets, they didn't get to put in space, and accidents and everything, that starts circling the Earth. I have worked on missions that they to remove space debris, and there are various ways to go about it. First, you need to probably get to the junk satellite or junk space debris, and then you capture it, and then you drag it down such that it's not up there potentially causing accidents. So I hope that answers your second question. Then you mentioned there was a third one, but I don't know if you already asked that.
I think that was
Actually,
it. Oh,
yeah, I think that was it.
That
Yeah.
was it. Okay.
Okay.
all right. Hey, everyone, let's give Dr. Fernandez a big round of applause. Wasn't this amazing? He has one of the coolest jobs, doesn't he? Thank you, Dr. Fernandez, for being with us today. It was very informative. I learned so much. I'm sure everyone had a great time. So we're at the point where we're going to take a nice photo with Dr. Fernandez. I'm going to invite all of you to turn on your camera and to give us a big smile. Okay. Remember, this is a special moment. Roman. Yeah, there you go, Roman. Can you set up, Roman? Yeah, there you go. There you go. All right. So I think we're all almost there. Okay, now everyone look closely at the camera. Yeah, I love that. One more time. Hold on a second. Ready? 1, 2. Okay, give me a second. Let me see how the photo came out. Ooh, I love it. All right. Okay, thank you again. So this was Dr. Juan Fernandez-Saldivar. Remember him. He's an optical systems engineer at Planet. And he just gave us an amazing talk of what he does at work. Remember that tomorrow we're going to have another talk, another special guest. We're going to have Guillermo Quiroz from Telemundo. He's the chief meteorologist at Telemundo. And we're going to celebrate Earth Day with us. He's going to help us celebrate Earth Day. All right. We want to celebrate it with all of you. Tell all your little buddies, all your friends, all the parents, your parents, if they're not with us because they're working, your big brothers. All right. Have them join us tomorrow. We're celebrating Earth Day, our beautiful planet. And now let me pause and remind all of you why we're doing this. You guys remember why we're doing this? Yeah, we're doing this because all of you are very special. Okay. We're doing this because we want all of you to do really well in school. Did everybody do their homework? Raise your hand. Yeah? All right. How about all the classwork today? You have to try extra hard, okay? To make sure you get a good grade in everything you do. Because once you finish in elementary and you get really good grades, middle school is going to be easier because you are creating good habits right now. Okay, you're creating the foundation of what it takes to be successful, what it takes to have a job like Dr. Juan Fernandez, what it takes to come and work for NASA. And once you go to high school, it's going to be a piece of cake. Believe me, piece of cake. Lots of fun, lots of hard work, but it's going to be a piece of cake. And when you get to the university, because all of you are going to the university, right? Then it's going to be a lot of fun, okay? And when you get there, you're going to be welcome to come and help us at NASA, at Planet, at Facebook, all these other cool places that are right here in your backyard. You guys live in Silicon Valley. This is the coolest place if you want to become an engineer, a psychologist, or a project manager, an engineer, a scientist like Dr. Juan Fernandez. But you have to do good, you have to do well in school. And you also have to be an excellent member of your community. Remember that, that's also very important, okay? You have to help us take care of our beautiful planet. Remember yesterday, Ms. Vianney Arana gave us some tips on how to make our planet much better. We have to take care of our home. We only have one home. And tomorrow we're gonna be celebrating, tomorrow's Earth Day. We're gonna be celebrating it together. All right, so we're gonna end it here. Thank you for joining us. Come back tomorrow, same time, same Zoom link. And thank you again, Dr. Juan Fernandez. Everyone, stay
Thank
safe.
you.
Take care.
Bye.
Bye-bye.
Thank you, everyone. Bye-bye.